We've encountered over and over and over again this basic idea about classes. And that is, class definitions have two main parts: instance variables or data, and methods or behavior. Whenever we instantiate a new object, it gets its own fresh, complete copy of all the instance variables. And whenever we call a method, it responds by activating that corresponding method in its own class. So if you think about it, objects really have two jobs. They contain data or their own instance variables, and they respond to method calls by invoking the code from the class. And classes have two jobs as well. They provide this sort of template or this blueprint for creating a particular type of object, and they store the code for the methods. So in other words, they get called eventually when we call a method, when we send a message like this to an object. So we might think of an object's instance variables as this sort of common pool of information that any method in the class can access. So when we call a method for a particular object, that means that that method has access to any of the instance variables for that object. So it's particularly helpful to split our variables into these two separate categories, those being instance variables, which are declared outside a method. We usually make them private, and any method in a class can access them. And local variables, which are declared inside a method. They don't get a visibility modifier, and we can only access them inside the method where they're declared. This leads naturally to the idea of scope. The scope of a variable is the region in a program where we can validly use it in a line of code, which means that the scope of a parameter or a local variable is really just the method that declares it, and the scope of a private instance variable is any method in the class. So we can see in this example, I've really got a bunch of different levels of scope. I've got this private instance variable, IAmPrivate, and that's accessible in either of these two methods, client method and helper method. Meanwhile, the parameters and the local variables declared in each method, client method or helper method, they're only accessible inside that method. They're not accessible in the other method. They each have local scope. A method's code can also have a sort of nested scope, which means that any variable we declare inside some compound statement with curly braces, we're going to say that has block scope. And those variables are only visible within the code enclosed by those braces. If you take a look at this code, there are two different levels of scope. For instance, there's the variable sum, which is declared outside our control structure here. It's declared outside the loop. On the other hand, the counter I and the int variable number are both declared inside the loop, so they're only accessible in there. As soon as that loop finishes running, those will disappear. We say that I and number have block scope, and that makes sense because they're only needed inside that loop. We never need them outside. Sum, on the other hand, persists. That leads quite nicely to the idea of the lifetime of a variable, which is really just our way of saying how long does this variable exist. Local variables and formal parameters in a method, they only exist during that single run of the method. So every time you call a method, we get a fresh set of those parameters and a fresh set of those variables. Instance variables, on the other hand, they're persistent. They last the entire lifetime of an object. So whenever we actually instantiate a new object, that's when it gets a fresh set of the instance variables. And those instance variables are available every time we call a method. They're sort of the object's memory. Finally, when a particular object gets garbage collected, it's no longer being used, that too is when those instance variables will get wiped. Now, because local variables and formal parameters are limited in their scope and their lifetime to a single method, we can use the same name for different local variables in different methods without actually causing any kind of conflict. You can see here in these two methods, client method and helper method, we name our local variables both IAmLocal. No problem. You can actually even use the same name for a local variable and a global variable, as we see here. In scope demo, we've got a private instance variable called IAmAVariable, and we see we've got a local version of that in the method sum method called IAmAVariable. Here we'd say that the local IAmAVariable shadows the instance variable IAmAVariable. Shadowing is dangerous because it makes it sort of unclear which version we mean. In this situation, if I were to refer to IAmAVariable without specifying which one I was referring to, it would default to the more local version. The only way to specify that I actually mean the instance variable IAmAVariable is to use the prefix this, as you see here in the method otherMethod. Here I'm setting the instance variable IAmAVariable to have the same value as the local formal parameter, IAmAVariable. I'm saying this dot I am a variable gets I am a variable. This is not really great practice because it's not very clear. However, it is legal. And just to be clear, the keyword this refers to the particular instance of the class that we're in. It's sort of an object's way of referring to itself. Now, with these different types of variables, it's important to have a good plan for when to use which type. Big idea is if we need an object to remember a piece of information, we want to store that information, that's when we use an instance variable. If we want to send information between two methods, that's when we'd use a parameter. And if we want sort of temporary working storage inside a method, that's a local variable. There's a bunch of ways to screw this up, so let's take a look at a few. Here's one way things could go wrong. Suppose I use an instance variable as temporary working storage. So imagine the student class. If I want to add an instance variable that keeps track of the sum, well then when I go to the getAverage method, if I start adding each score to sum, eventually I'll see that sum doesn't actually reset on its own when getAverage finishes. So this method is only going to work a single time because it's going to keep taking every single test score every time getAverage is called. We never actually reset it. The better way would be to declare a local variable sum inside the getAverage class. That way it gets wiped every time getAverage finishes. We return the value and then the next time we'd start fresh. I could also accidentally use a local variable if I'm trying to remember some information for an object. Here's an example where in the method setName, I accidentally declare a new local variable name. Whenever in this method I were to refer to name, it would default to the local version rather than the instance variable. So in this setter, if I'm saying string name equals nm, I'm actually losing whatever parameter was passed here. This setter is broken. And the only way that I could specify that I meant the instance variable name would be to use this dot as a prefix, this dot name. If I try to use this to change the name of this student, that change is going to disappear. Third thing to keep in mind is that you might use an instance variable when you could have used a parameter instead. If you think there's really two ways methods can communicate with each other, they can either share this common pool of resources, this common pool of instance variables, or they can pass messages back and forth between each other using parameters and return values, or inputs and outputs. The first good reason that we would prefer parameters and return values to instance variables is that if methods are sharing this pool of instance variables and one of them misuses one of the variables in some way, it just does something wrong, it changes the value unexpectedly, just things go wrong, it can be sort of hard to figure out where that's happening because you have a bunch of different methods that are all changing the same values. In this code example in the server class, M1 sets the value of some instance variable x to 0, and then M2, the second method, uses x as the divisor in the main line of code, int y equals 10 divided by x. When we run our client class, it's not totally obvious what the cause of this is. And there would probably be a good way to do this without relying on the instance variable x. Second good reason is that if we're working with a bunch of methods in a class, we want to be able to really thoroughly document and understand the relationships between those different methods. And so when we're explicitly defining how they're going to interact, when we're saying what parameters they take and what exactly they'll return, that means we're doing a thorough job explaining all of that, and we're sure to have a better understanding of it. It's best when we explicitly spell out those contracts. Finally, any code that I write that relies on a particular object structure, relies on a particular set of instance variables, you can only use that code in its original context when it has all of those instance variables. If you write code that takes parameters instead, that's easier to port to different contexts. Big idea here is that instance variables are powerful and they're a useful feature of object-oriented programming, but we want to minimize our use of them. We want to make sure that we're only using them when they're truly appropriate, and we want to use them judiciously. That means really only using them to track the state of an object and using local variables and parameters whenever we can otherwise. Before we close up shop, take a look at these questions. Make sure you can talk about the lifetime of an instance variable, a local variable, and a parameter. Also talk about what their uses are. Talk about what shadowing is. Make sure you can give an example of when it happens, what the problem might be, and what explicit thing you have to do to counteract the effect of shadowing. And take a look at this code segment. Make sure you can identify what the instance variables, parameters, and local variables are, and describe the scope and lifetime of each. That's it.